Okay, algebraic expressions. The letters in algebra are called variables because they vary from problem to problem. The numerals are called constants because they remain the same from problem to problem. There's constant, right? A numeral 3 has a value of 3 in every problem that contains it. But an x might have a value of 3 in one problem and a value of 12 in another problem. It varies from problem to problem. Now, what we want to be careful about is the difference between an expression and an equation. Expressions do not have an equal sign. You cannot solve an expression. You can only simplify or evaluate. Equations do have an equal sign. Half of the word, look, equate, is about equal. So you solve equations. You find out what the variable equals. I cannot tell that in an expression. And that's what we're talking about here, algebraic expressions. So let's get some more terminology. Terms are those things that are separated completely. Notice the word completely by plus or minus signs. So why did that arrow, let me see if I can get rid of that arrow. Every now and then it pops up. I'm not sure what I do to do it. Okay, click on that. That's what I do, maybe. Okay, sorry guys. I don't like that either. All right, let me see. Trying different clicks. All right, we'll deal with it. Okay, so for example, this expression has 1, 2, 3, 4 terms. They're separated completely by those plus and minus signs. This one has 2 terms. But this one has 1 term because even though there's a plus sign in here, this 5 isn't separated completely from the 2 by plus or a minus sign. It's hooked with multiplication. So be careful about that. Terms are separated completely by plus or minus signs. The coefficient is what we call the numerical part of the term. Okay, and remember the sign in front of the number is part of the number. So the coefficients of this expression are 3, 5, -7, and 4. Coefficients of this one are 5 and 2. We can also call these terms that don't have a variable constant terms. Okay? Like terms are terms that are exactly alike except for the coefficient. They got to have the same variables and the same exponent. So 2x and 5x, they are like terms. 2x and 5x squared are not like terms. It doesn't matter about the letter. Everything's got to be exactly alike. So 7x squared and 5x squared are like terms. And when we are dealing with expressions, we cannot solve them. We can only evaluate or simplify. Evaluating means we have to be told what the variable is. So I can evaluate this expression, notice no equal sign, if I know that y is -2 and z is -6. That just means put a -2 everywhere there's a y and a -6 everywhere there's a z. So -6 over -3 times -2 plus -6. I just replaced every y with -2, every z with -6, and then there's not any variables left. It's just simplify. Use our order of operations. Okay, so remember, parentheses first, and numerators and denominators are like invisible parentheses. Okay, so up here, there's only one step to do. right? The negative is being squared, so negative 6 times negative 6, positive 36. And down here, as I'm rewriting it, I'm getting rid of those stupid double signs, right? I do not like the double signs. Signs are different, it means minus. Okay, so now I'm working down here. There's nothing inside the parentheses to do. There's no exponents. Multiplication and division first. Negative 3 times negative 2. Positive 6 minus 6. Oh, what do we call that? What do you call that when you have a 0 in the denominator? Undefined. Okay, so I can only get a value if I'm evaluating an expression. Now, in the rest of them, we're just simplifying. And that means I can combine like terms. That's all I can do. So the first thing I'm going to do is I'm going to go and see if there's anything else that's an LN. The only thing I can do is combine any of them that's an LN. Here's one. Oh, they're all LN. So remember our commutative property? If I wanted to, I could change the order of this. I could just go straight across. But if I put all my positive ones first, it might make my math easier, because 10 of these MN things plus 3 more, that means altogether I'd have 13 MNs, whatever an MN is. And then if I want to take 12 of those same things away, I'd wind up with just 1 MN. And if we have a 1, we usually don't put that, right? Like, look, that means if there's not a number written right in front of your letter, it means it's a 1. Okay, so over here, the only thing I can combine is if there's any more R's. So I'm going to look for all the R's and add them together. So negative 9R minus 5R. Signs are the same, so I'm really going to add the numbers. So that's 14. Keep the sign in front of the biggest one. So that's negative 14R. Take away one more R. Negative 15R. The rest of it is just going to stay the same. Okay. Now I've already done my R's. Now I'm going to look for T's. Sorry, guys. I'm going to look for T's. Ah, come on, pencil. Okay, and notice here, I notice that, hey, I got a 6T minus 6T. All right, 6T minus 6T. So all I have left is a T. Now the R's we've already done. Now we have plus a T. Okay, so the rest of everything, I've done the R's and the T's, is going to stay the same. Okay, so now we have all of these are S's. And look, minus 15R plus T plus 5S. Okay, I suggest you find some way to account for the ones that you've used, so I can quickly tell by looking at this that I've used every letter. Okay, I know we don't have different colors. I do in here, so I kind of expanded on that, but typically I do this. And so on the next ones, I'll keep it with what if we don't have different colors. Let's just go with that. So the only thing I can add to this is if I have anything that's just an A squared. Not A squared, not A squared, not A squared. Okay, now I'm looking for ABs. That's not AB, that's a B cubed, so it doesn't work. A cubed B, no. AB cubed, not the same. And then a different one, and I can tell quickly by glancing that I've accounted for every term. Okay, let's get rid of parentheses. That's always the first thing we do. Remember our distributive property that allows us to get rid of parentheses if I can't combine the terms inside the parentheses. They're not alike. I can't combine them. So my other option is use my distributive property. So I'm just going to use the distributive property. Plus 4 times minus 3 minus 12b plus 4 times plus 3 plus 2 times 6 times b, positive 2 times negative 1. Okay, so get rid of parentheses. Now, the only thing I can add to this is if I have another constant, another number without a letter. Oh, and there's one, and there's one. 12 minus 10 is 2 minus 2. Oh, and I kind of reserve the slash for if it goes to 0. Oh, look at this one also. Negative 12b plus 12b. Okay, looks like this one's missing our bracket there, typo. All right, get rid of parentheses first. Inside parentheses, the others are staying. 4x minus 36 plus 1. Now, inside these parentheses, there's like terms, so they stay. Minus 36 plus 1, minus 35. When there's nothing left to do inside the parentheses, I can distribute to get rid of them. So 12x minus 105. None of the other terms are alike, so I'm done. Okay, inside parentheses, now there's nothing I can do inside here, but if there's not a number written, it's understood to be a 1, right? So I'm going to distribute negative 1. This 2 is not being multiplied by here. There's a sign by my parentheses, so the number has to be a 1. Everything else stays the same, except negative 1 times 2 is negative 2, and negative 1 times negative 5y is positive 5y. Now I'm still working inside my parentheses. Oh, 2 minus 2. Okay, I have a multiplication here. Negative 3 times 5y, 2, that's minus 15y, and those aren't like terms, so I'm done. Okay, inside parentheses first. And here's another parenthesis. So 24x squared minus 42. Got a minus there, but this one stays. Now 81x squared minus 9 plus 2. Nothing here can combine, but in here these can combine. So 81x squared minus 2 plus 9 is minus 7. Okay, now I still got to get rid of these parentheses because there's not a number right here. It's understood to be a 1. So that's what gets distributed. So 24x squared minus 42 minus 81x squared plus 7. Minus 1 times minus 7. All right, now here's x squareds. 24 minus 81. Signs are different means I'm really going to minus those numbers. So if I have to come over here to subtract those numbers, that's fine. 11 minus 4 is 7. 7 minus 2 is 5. and you keep the sign in front of the big one. Okay, now these are both constants. Different signs means minus. 42 minus 7 is 35, and keep the sign in front of the biggest one. All righty.